Lesson 2-3, solving systems of equations graphically. Now there are three methods that we're going to look at for solving systems of equations. The first one we're going to look at today is graphing. The other two are substitution and elimination. First with graphing, if you're comparing the graphs, you have some systems where the lines intersect at one point, where the lines are identical, which means it looks like one line, but it's two separate lines, but they're the exact same line. And then we have lines that are parallel. If we look at the equations of the lines have different slopes where they cross once. The equations have the same slope and y-intercept, which means they're the same line. And lines that have the same slope and different y-intercepts, those lines will be parallel. When you compare their solutions, you can have one solution, which means they cross in one spot, infinitely many solutions, which means any number you put in there will always be a solution, or you can have no solutions where the lines do not cross. Now, when you classify these systems, you can classify them as consistent or inconsistent. Consistent if they cross, inconsistent if they do not cross. And then if you say it's consistent, that means you have to classify it even further as dependent or independent. So if it crosses in one spot and only in one spot, it would be consistent and independent. So this would be consistent and independent here. The middle one, this crosses, so this is consistent, but it crosses in more than one spot. So that's consistent and dependent. And the last one, they never cross. This would be just consistent. So let's take a look at some examples by classifying based on the equations. So determine the number of solutions the system has, then state whether the system of equations is consistent or inconsistent, and whether it is independent or dependent. So I'm going to solve for y by dividing by 2 here. I have y equals 3x minus 7. And over here, if I add y and subtract 7, I now have y equals 3x minus 7. I notice that my slope is the same and the y-intercept is the same. So that means this would be many solutions because they're the exact same line. That means this is consistent and dependent. Next example, solve for y here. So I'm going to subtract 3x. Now I have negative 2y equaling negative 3x minus 7. Divide by negative 2. I would have y equals 3 halves x plus 7 halves. And over here, just divide by 4. I would have y equals negative 2/3 x, or not 2/3, negative 3 halves x plus 9/4. Now I notice that my slopes are not the same and my y-intercepts are not the same either. That means this has one solution and this is consistent and independent. Just means two separate lines, but they cross at only one spot. Next, determine the number of solutions and classify these. So this one I can rewrite as y equals negative 8x plus 4. And this one would be y equals negative 8x plus 7. The slopes are the same, but the y-intercepts are different. So they will not cross because they're parallel, so no solution. And we would say this is inconsistent. Next, this would be y equals, subtract 4x and then divide by negative 5. So this would be a positive 4/5 x plus 7, because negative 35 divided by negative 5 is positive 7. This next one here would be y equals, or add 9x to both sides. This will give, and then divide by 10, so that will give us positive 9/10 x plus 6. Two different lines because the slopes are different and y-intercepts are different. So this is one solution. And this is consistent. And this would be independent. Example 2 is now going to be graphing them. So to graph them, it'd be easier to put them in y equals mx plus b format. For this one, this would be y equals, I'm just flipping the y and the 3 around, so this would be 5x minus 3. And this one would be y equals, add x to both sides, so it would be x plus 5. So let's graph them, put a point at negative 3, up 5, to the right 1, or you go down 5 to the left 1. So there's my points, now I can draw my line. And the red one, I put a point at 5, has a slope of 1, so up 1 over 1, up 1 over 1. So our line will look like this. Crosses here, so the point, only one spot, so this would be at 2, 7. Next, solve this one. So here, if I subtract 14x and then divide by 2, this would be y equals negative 7x minus 3. And the other one, I would subtract 8 and then divide by negative 4. So that'd be negative 8 divided by negative 4 is 2x. Negative 24 divided by negative 4 is a positive 6. So I'll do that one first. So put a point at 6. Go down or up 2 to the right one, or I go down 2 to the left one. I can draw my line here. And the other one, put a point at negative 3. Has a slope of negative 7, so I can go up 7 to the left one. I know where the lines cross, so I can just draw my line here. Crosses here, so that would be negative 1, positive 4. Next example, graph these and solve. I'll do this one, so this would be y equals positive 5x minus 18. And the other one would be y equals, divide everything by 3. So this would be negative 3x plus 6. If I plot that one, that would be negative, positive 6, down 3, the right one. So I have my slope here, going down, so I can draw my line. The other one, since I can't go to 18, I'm just going to pick some points in there, think it'll work. So if I put a 2 in for x, I would have 5 times 2 is 10 minus 18 gives me a negative 8. So 2 negative 8 would be down here. If I put a 3 in there, that's 15 minus 18 gives us negative 3. So 3 negative 3 be here. If I did one more, 5 times 4 is 20. Minus 18 is 2. So 4, 2. I can draw my line. See, they meet here, so the point or their solution would be 3, negative 3. Next, solve these ones. So solve this one, subtract 7x and then divide by 2. So this would be y equals negative 7 halves x plus 8. And the other one, be y equals add 21x and then divide by -6. So we would have 21 divided by -6. As a fraction, that gives us -7/2 x. And 24 divided by -6 is a -4. You'll notice that my lines are, or my slopes are parallel, are the same, so they're parallel. The y-intercepts are different. So I know this is no solution, but to graph it, put a point at -4, go up 7, to the left 2. I can draw my line. And then the red one, put a point at 8. And go down 7 to the right 2. There you can see the lines never cross because they're parallel, so no solution. Next one, here I would add 6x and then divide by -2. So 6 divided by -2 will give us a -3x. -10 divided by -2 is a +5. And then this one, I had y equals subtract 15, -15, then divide by 5. That would give us -3x. 25 divided by 5 is a +5. So I have the two exact same equations. So this would be many solutions. But to prove it on a number line, I'll do the black one first. So I put 5, go down 3 to the right one. And then the blue one, put a point at 5, down 3 to the right one, down 3 to the right one. Draw my line. They're the exact same line. Our next question is a word problem. It says, suppose an electric car costs $29,000 to purchase and 0.036 per mile to drive, and a gasoline-powered car costs $19,000 to purchase and 8 cents per mile to drive. Estimate after how many miles of driving the total cost of each car will be the same. In part A, write the equations. Part B, examine the graph to estimate the number of miles you would have to drive before the cost of owning each type of car would be the same. So for the equations, I would have for the electric car, y equals 0.036x plus it costs $29,000. And the other one, y equals costs 8 cents per mile, so 0.08x plus 19,000. Now this will be easier to do it on our graphing calculator, so I'll grab our calculator here. And our y equals, and we'll type in our equations, so 0.036x plus 29,000. And the second one, we have 0.08x plus 19,000. I'm going to change my windows. My x is going to be 0. That's the minimum I can have. So the 0 miles driven. The maximum, we'll count these by 30s and we'll go to 270,000. Count by 30,000. The y minimum is 0. Let's count these. The y maximum, let's do 45. And these are in the thousands, so let's do 45,000. And we'll count by 5,000s. Now if we hit graph, there's our first one, the electric. Here's the gas-powered one. They cross roughly here. So if I hit second, trace, I'm going to find out where they intersect, number 5. Hit enter 3 times, and it tells us 227,272 would be the miles. We can say roughly 27,000 miles, it would cost $37,000. Or if you round to the nearest hundredth, would be $37,200. Now here you can see the same graph, very similar. So you can see the standards, they just counted by, put it in parentheses that they're counted by thousands in here. So the number of miles you have to drive before the cost of owning each type would be the same. So if I grab my calculator again, X would be our miles. So let's do 227,000. I'll do 227,300. And the cost would be $37,200. Going on to our next problem. It says Westside Gym charges members an initiation fee of $45 and then a monthly membership fee of $9. Eastside Gym charges its members no initiation fee and a monthly membership fee of $12. Estimate after how many months the total cost of memberships in each gym will be the same. And then we're going to write our equations and then we're going to examine, determine when will the cost be the same on this one. So let's go through the equation. So the first one, we have y equals, so this would be the west side, fee of $45 and a monthly membership fee of $9. So 9x plus 45. And east side would be, there's no initiation fee, so it's just a monthly of 12x. So again, if we grab our calculators, go to our y equals, we have 9x plus 45, and the other one, so 9x plus 45. The other one is just 12x. Change our windows to 0. Make this, let's make this maximum. Let's do 20. Count by 2's. The y minimum 0. The maximum, let's do 500. We'll count by 25's. See if that works. There's our first one, west side. Here's east side. Crosses right here. Hit second, trace. Number 5, intersect. Hit enter 3 times. It says they intersect at 15. And x is 15 and 180. Part B, here again, you can see our equations here. For this one, their graph here is off a little bit because they're starting at 40 when we were told that it starts at 45. So we're not going to use this graph here. We're going to use the graph that we created here. So if we hit graph and we go to second trace, number 5, you can see first curve, hit enter, second curve, hit enter, gas, hit enter, 15 and 180. So that means after 15 months, they both will charge $180. Going on to our next part. Let's use a graphing calculator to solve the system of equations. Here, so we have decimals here, and when you have decimals, it's probably going to be easier to use your graphing calculator here. So these are the steps you're going to use. Step 1, put the equations in slope-intercept form. Enter the equations in the y equals button. Click graph. Click second trace. choose intersect and hit enter 3 times and round to the nearest hundredth if you need to. So for this one, let's put this into y equals mx plus b. So this one would be y equals, I have to add 5.6 to both sides. So if I have 5.6, and then I'm going to divide that by 3.5, which will give me 1.6 x. And then I already have 18.2 on there. I have to divide that by 3.5, which will give me plus 5.2. This one would be, I'm just going to switch the y around and the negative 2.4. So this is going to be negative 0.7 x. And this will be plus 2.4. Now if we take our calculator here, put our y equals, type the first one in, 1.6 x plus 5.2. The other one would be negative 0.7 x plus 2.4. If I hit graph, here I'll have to change the window settings. Let me do zoom number 6. There you can see what we would have here. Since there's no word problem on this one, I can have negative numbers here. So second, trace, number 5, intersect and hit enter 3 times. To the nearest hundredth, so 2 decimal places, I would have negative 1.22. And our y would be 3.25. And that's where they would intersect. Next, use the graphing calculator for this one. Then we'll rewrite this. This would be y equals to 3.78 divided by 5.4. That gives us 0.7x. Then 10.8 divided by 5.4 gives us a positive 2. Here I'd have y equals 2.1x, and then I would have a minus 6.5. Take our calculator again. Go to y equals, we have 0.7x, and then we have plus 2. And the second one, we have 2.1x minus, and we got 6.5. Graph that one. There's the first one. Here's the second one. Hit second, trace, number 5. Hit enter 3 times. Crosses at 6.07. And the y would be 6.25. Next, solve this one with a graphing calculator. So let's move this over a little bit. So for these, each side is an equation. So this is an equation, here's the other equation. So I have 4.5x minus 3.9, and the other one would be 6.5. Actually, let's delete that. This would be negative 2x. Let me go back to that. So negative 2x plus 6.5. Then if we hit graph, here's the first one, here's the second one, crosses here. So I hit second, trace, number 5, hit enter 3 times. We would have 1.6 and 3.3. And our last question here. So this one, and we'll grab our calculator again. y equals, we got 5 point, I'll put this as 0.3x. And then we have plus 5.8. The other one we have 4.9x minus 7. Graph that one. Here's the first one. Here's the second one, crosses here. So I hit second trace. Number 5. Hit enter 3 times. 2.78. And our y would be 6.63. And that would be our solution of where the two lines meet. That is our lesson on solving systems of equations graphically.